Welcome to the Interventionals channel once again. Uh, Today marks the beginning of our scheduled module discussion on FRCR physics. We will stick to precise topics and which are very relevant to you for both any FRCR or any similar competitive exams. Maybe it MICR or anything similar. So today we are going to discuss on introduction of radiology and X-rays. And once again, I want you guys to go through the schedules which I have uploaded earlier. The link will be towards the right side of the box here. You can click on that and go through the module plan. And next video will be the video on some FRCR pre-questionnaires which I have posted before posting this video. First, go through the pre-exam questionnaires, try to note down the answers, and then only jump into this session today. So once again, let's begin. I hope this will be an interesting session. So today's discussion objectives will be to understand about electromagnetic radiation and introduction to X-rays, Bohr's, and we will be discussing about atomic structure. We will be discussing on Bohr's model of atomic structure, and we have to know about the important elements or elements in the periodic table for us as radiologists and radiotechnologists. Which all atomic elements are important for us. So there are certain numbers of elements which we require. The most important being tungsten, and maybe the second most important being lead. Okay, and so that is one thing. And at the end of the session, we will be discussing the FRCR question, which will be another session altogether indeed. So this we will do in later sessions. So let's go ahead with the first topic, that is introduction. So what do you mean by electromagnetic radiation? This is there are so many descriptions regarding electromagnetic radiation in almost all textbooks, chapters and all. One of the textbooks which I followed when I did my first year in radio diagnosis was FARS, and we also had Christensen. So in that they have given a very good explanation, but so far this is one of the best explanation which I have came across after understanding the topic. So electromagnetic radiation can be explained as electric and magnetic disturbance traveling through space at the speed of light. Uh, that is around 2.998 into, this is actually 10th power of 8. So it is not 180, so millimeter per second. So it contains neither mass. So this is very important. So electromagnetic radiation does not contain mass and does not contain any charge, okay, but travels in packets of radiant energy called photons or quanta. Okay, so basically electromagnetic radiation is packets of energy traveling as electric and magnetic disturbance at the speed of light. So the easiest way to remember speed of light is, we all have studied in our earlier days, it is 300,000 kilometer per second. Okay, so that is the easiest way to remember it, but this is a little more accurate representation of the same, and it is in meter per second. So do check in FRCR, they might have tricky questions like this. See whether the denotations are correct. 3 lakh is for kilometer per second and this is for meter per second. So next important topic is regarding what are the electromagnetic radiations which we know of. So we know of a lot of electromagnetic radiation. So the first one being radio waves to microwaves. Then we have our ultraviolet rays. Then we have our visible spectrum light. Then we have gamma rays, X-rays, etc. Now, so we just described this in one manner. So we have described that electromagnetic radiations are energy traveling as electrical and magnetic disturbances. But there is another explanation for this as well. So these that explanation in that explanation what it mentions is that where for packets of energy travels as waves, like crests and troughs of waves. So for that to understand, you should understand this image. It's a very simple representation of the entire electromagnetic spectrum. So the middle being visible spectrum of light. So this is the approximate wavelength of each. So what do you mean by wavelength? So that is one question you have to understand first. So wavelength represents the distance between two crests or distance between two troughs. So this is wavelength. This is called wavelength. So this is also called wavelength. So it is the distance between first crest and the second crest, or it is the distance between the first trough and the second trough. So here you have another question here. So wavelength of an X-ray is represented by the distance between the two crests. Then answer is true. So that is a scenario here. So as you can see here, the radio waves, the wavelength is higher. Meanwhile, when you come towards gamma rays, the wavelength is lower. So as you can see here, what is the wavelength is given here. So it is in terms of millions, and in X-rays it comes around 0.5. So this is important. Okay, so 0.5 is the representation here. But energy, see the difference between the energy. So as you can see here, the energy of radio waves is very less. Meanwhile, in gamma rays, the energy is so high, as you can see here. So what does it say? So energy is inversely proportional to wavelength. No, actually energy is directly proportional to energy is directly proportional to frequency. Okay, so that is how it works. Okay, and wavelength, which is represented in lambda, is inversely proportional to frequency. So that's how it works. So given that, we should understand this. As you can go from here, what do you mean by frequency? So frequency means that number of waves generated per second. So if you go towards here, you can see the waves have become crowded. So this represents more frequency of waves. So that is how it is simply explained. So now we'll go back to the previous slide. So c is speed of light. So velocity equal to multiplied by lambda into mu. Mu is actually representation of frequency. So when the velocity remains constant, as I earlier showed, frequency is inversely proportional to wavelength. So that's how we have worked it out. So remember, velocity is constant for all electromagnetic radiation. So it will travel in the speed of light. So this is a very tricky question which has been asked multiple times in FRCR. So the question can be like this. X-ray travels in the speed of photons, speed of visible light in certain media, whether it is true or false. It is true. Then another question came like this. The speed of light is similar to that of speed of X-rays. That is again true. So remember that this is how you have to study now on, like how to prepare. Understand the topic and then go ahead. So as you can see here, wavelength keep on decreasing from radio waves to gamma rays. So that visible light, if you take visible light here, visible light will have less wavelength compared to radio wave, but more wavelength compared to X-rays. So that is the importance here. So visible light will have same velocity of X-rays, but visible light will have different wavelength and different frequency compared to X-rays. So that is another point there. Please note down that. So going to the next slide. Okay. So as I mentioned earlier, how we calculate the energy. Energy is equal to the frequency of the electromagnetic radiation multiplied by a constant called Planck's constant. This is the equation. Another one of important equations here. So Again, these are the topics I've just told you. And one more important thing, as I mentioned in the description, photons have no mass but have energy. X-rays travel in straight line in the speed of light, no deviation of path due to external electromagnetic field. This is very important. This has been asked in FRCR, and the answer is true. Now we'll come to one more point here, which I would like to discuss here, especially now. The point being is, if X-rays travel in straight line at the speed of light, how will you change the direction of the X-rays? So answer is simple. When it interacts with matter. So interaction with matter, please don't mind my handwriting. It's very difficult to write using a mouse. Plus, my handwriting is not that good. But I think it's enough. Okay, so interacts with, when X-ray interacts with matter, it can change its direction, as we have seen in the case of multiple ways where we have Bremsstrahlung, then we have to remember one more point. These high frequency electromagnetic radiations have ionizing properties. So X-rays, gamma rays, other charged particles like beta rays, alpha rays, all are ionizing radiations. So what do you mean by ionizing radiation? Ionizing radiation means any radiation, be it electromagnetic radiation or not, or a particle. Electromagnetic radiation, if it is an electromagnetic radiation, when it passes through matter, it can deposit energy to matter, and this energy, when it interacts with tissue at the atomic level, it can produce positive and negative ions. So this is ionization in simple way. So electromagnetic radiation interacting with matter can deposit energy in tissues, and that in turn producing positive and negative ions. So this is how you discuss electromagnetic radiation. So now coming to atom atomic structure, very important part of our discussion today. So we have different people explaining about atoms over the year. So J.J. Thomson has one type of model in which he had said atom is composed of loosely arranged positive and negative charged particles. He didn't find it to be saying that there is a nucleus or anything. Then Rutherford came and he described that the presence of nucleus and then surrounded by negatively charged electrons. And he did this using one of his famous experiment, which I hope you all remember in your earlier physics classes, which is called gold foil experiment. Just read about it if you want to understand. He had done by observing the change in direction of electron when he tried to pass it through a gold foil, thin gold foil, and he interpreted the change in energy and deviation. Based on that, he had concluded that this is the structure here. So the first experimental model of an atom has been generated by Niels Bohr, and it is been widely approved and widely used for understanding various things in radiology by using Bohr's atomic model. So that's why this is essentially Niels Bohr or Bohr's atomic model, in which you have a centrally placed nucleus surrounded by electrons. So in each, and electrons are arranged in each shells or orbits, or we can call it as energy levels surrounding the circular orbits or energy levels surrounding the nucleus. So why it arranges in these levels? So the thing is that each level has a different kind energy. So the closer the shell is, the the energy level of the electrons are lesser, or the binding energy is more while the electron energy is less. Meanwhile, the outer electrons are very loosely bound with the nucleus, and those can be kicked out easily. So this outermost shell of an atom is called a valence shell, and the electron in that, those are called valence electrons. Okay, and the most tightly bound electrons will be in the K shell, that is the innermost shell close to the nucleus. So I hope this is clear to you all. So one interesting fact here is each shells have subshells or sub energy levels. Now coming back to discussion regarding FRCR points here. So atom. So atom is composed of a nucleus which is surrounded by electrons in different shells. So we have K, L, M, N, O. And the order of arrangement according to Rutherford model is K shell has 2 electrons. So this is like the maximum capacity which each shell can hold. So if you are thinking about K shell, the K shell can only hold up to 2 electrons. L shell can hold up to 8 electrons. Similarly, M shell can hold up to 18 electrons. N 32, 32, etc. So after M shell, there will be more and more subshells or sub energy levels in the orbits. So it becomes a little hazy after that. So we don't have to bother about that right now. We'll just focus on what is important for the exam perspective now. So nucleus, what is nucleus? So this is again an important point which is asked very often. Nucleus is composed of protons and neutrons. And in a stable atom, that remember that in a stable atom, both protons and neutrons are in equal number. A nucleus has a positive charge, which is negated by electrons, which has negative charge, and the electrons are negative charge and which will be equal to number of protons in a stable non-ionized atom. So we will come to that in a bit. What is a non-ionized and ionized atom? So now the question they ask in FRCR very commonly is that the nucleus, about the nucleus they can ask is nucleus composes of protons and electrons. Wrong, answer is wrong. Nucleus composes of protons and neutrons. Now neutrons are positively charged. I have seen this question came in all of the exams. So what is that? No, neutrons have no charge. Okay, but nucleus has mass. Remember that. Electrons has very little or negligible mass. A single electron has no mass. Okay, so I think I'm clear with all these explanations. So you can see it here, protons and no charged neutrons. So 1, 2, 3, something like that. This is not an exact representation. It's a 3D model. So right now, how many electrons we have here? 1, 2, 3, 4, 5, 6, 7. So total 7 electrons are there. Then the nucleus should have 7 protons and 7 neutrons. Then only it will be a stable atom. Okay. So in a stable atom, the number of protons equals number of electrons equals number of neutrons. So remember that. So a periodic table of the elements are very important. So this is our classical periodic table. Every now and then new elements got added upon. So in this, molybdenum and lead and some other elements on the way we have to understand. So what is the atomic number of tungsten and what is atomic number? How is it represented? So these are the questions next, which is important in FRCR. What is the symbol of tungsten? So many of us think it is T. No, wrong. It is not T. It is not T. It is not true. So tungsten is represented by letter W, which actually is representative of something called wolframite. Okay, so wolframite. Okay, so wolfram, tungsten's alternative name is wolfram. Okay, so it was the first name given to tungsten by the person who had discovered tungsten. So wolframite is the element or mineral mineral from which tungsten was discovered. Okay, wolframite. So it's a mineral. Okay, so that is W for you. So now tungsten or any atom, how will you represent in a periodic table? So you can see different numbers here. So our tungsten is somewhere here. You can see here, tungsten is here. I think it is too small for you guys to see, but I hope you can see this. Tungsten is here. So in periodic table, tungsten is lodged between chromium, molybdenum, tungsten, and one more element called Sg. It is called terbium. So molybdenum comes essentially above it. You can see here, this is molybdenum, and you can see here, this is molybdenum. So representation of an atom in a periodic table will be like this. So let's go with tungsten itself. Tungsten symbol is W, and below it we will be representing atomic number, that is 74, and above it we will be representing the mass number. So mass number of tungsten is 183. Okay, 183 and 74. So 74 is the atomic number and 183 is the mass number. You guys have to make notes of this and keep it with you so that it will be useful for FRCR exam. So right now you have to understand one more point. Mass number is denoted by the alphabet A, and atomic number is denoted by the alphabet Z. Okay, so you should understand this. So mass number, atomic number. So that's how you understand it. So tungsten, atomic number is 74 and mass number is 183. Okay. Now coming to molybdenum. So again, how will you write molybdenum? Molybdenum's atomic number is 42. Mass number is 95. So how will you write? Like this, 72, 95? No, wrong. This is wrong. How will you write it? How will you write it? You write it like this. You write the symbol here. Atomic number is always represented in the lower half, that is 42, and mass number in the upper portion, that is 95. And this is how you represent it. So this is what I wanted to discuss with you guys today, and we will continue the discussion in the next video as well. So this will be how we are going to do things here. It will help you in solving some of the questions of the FRCR questionnaire which I have given to you. Please go through that, find out the answers, and then we will discuss the answers along with some more regarding this topic in the next video. Thank you guys. Stay tuned for more. This is the pilot video of the physics module series now. I hope if you find it interesting and useful and you have understood the concept, do invite your other friends or colleagues to our channel, that is the Interventionist. Please don't forget to subscribe to the YouTube channel. That makes a lot of difference. Thank you.